eating breakfast, but I'm Chris Greig, Director of the UQ Energy Initiative, and it's my pleasure to welcome Professor Robert Socolow to the floor to address the topic of fossil fuels and climate change, limiting the damage from the collision. I think Max gave Rob all the introduction he needs, and as Alex Apanis and I were discussing when we were selecting the speaker for this event, he's a rock star in this area. So, Rob, welcome.
I'm waiting for an introduction someday when someone says, this guy's isn't going to tell you very much. Lower your expectations. Then you have a chance. Rock star, my God. But I do want to acknowledge Max Liu's introduction and say that I knew him when, and it's quite exciting to see this meteoric career of a man who came in his 30s and spent half a year with us in the group that I run, and it was a pleasure to have him at the time. He was enormously productive. He reminds me that we even jointly authored a paper which he took 90% of the role in, as I would imagine. Anyway, it's great to be introduced by Max and then by Chris, who was a new friend of mine and of my colleagues in a very productive relationship, which is making some particular work at Princeton far more credible than it would have been without him. So I have come up with a new title for a talk that is a new talk, but I particularly ask myself, do I have anything at all to say to the fossil energy industries at a time when the climate problem is more and more asserting itself? And I'd like to start with a quiz. Professors do that sort of thing. I'm going to ask you, each of you, in about a minute or less, to decide which of four quadrants you personally feel most comfortable, believe in, where you are, where you have to answer two yes/no questions. The first is, are fossil fuels hard to displace? And the second is climate change an urgent matter? Take a couple of minutes, and I'm going to poll the group and see how the group distributes in terms of these four quadrants. Okay. Is anyone in the top left? Nobody is in the top left. Is anybody in the top right, where the fossil fuels are stubborn competitors? They're going to not be folding anytime soon, but climate change is really greatly overrated. Now I've got 2, 3, 4, 5, 6 type positions. Good. What about because people are being honest when they do that, and I admire that. People in the bottom left are going to believe that fossil fuels are really quite fragile. They've had a big market share, but just a matter of a few more inventions and a few more policies, and they'll be more or less leaving the stage. But climate change is really serious. Is anybody in that quadrant in this room? 1, 2 over there, 3, good, 4. So those two quadrants are not empty, and the bottom right is most of the room. It isn't most of the room in many audiences, as you can imagine. So if we try to characterize what would bring someone into one quadrant or another, the top left is not a terribly likely quadrant for most people, because you would have to simultaneously believe that, but there are people who would believe that if we had no climate problem at all, renewables or nuclear, depending on which group you're in, is simply the way to go. The nuclear community in the 1970s, 60s and 70s, when I was getting into this subject, was really there. They hadn't heard of climate, and they thought that nuclear power would put coal to bed once and for all. Many people in the fossil fuel industries are in the top right, and many people in the renewables world and in the driving factors in the IPCC, for example, are in the bottom left. The bottom right is the hard place to sit in, where you have to confront what's called cognitive dissonance. You have to believe two things that are in the way of each other. If you want to go to bed at night and have a good night's sleep, you'd much rather be in the bottom left or the top right quadrant, where there's not an internal contradiction. I've also added temperatures for the sake of play, if you like, that the 2-degree world, which is the world of the most recent Paris Agreement, is a world in which fossil fuels can be pushed away relatively easily by national policies and will be pushed away. And the upper right, which is certainly the world of many of the people in the energy industries in the United States, I would bet it's a dominant quadrant for Houston, Texas, climate change is just going to disappear. It's a bad dream. Senator Inhofe from Oklahoma in the United States calls it a hoax. And that would lead to a climate change that would really be almost certainly a very severe change in the planet we live on. And perhaps there is a middle ground, but it represents both a lot of work and a lot of acceptance of how hard the job actually is. The way I put it is to remember a childhood puzzle that I enjoyed. I guess you would call it a paradox. How many of you can remember playing around at age 9 or 10 with the sentence, what happens when an irresistible force meets an immovable object? You know, what does happen? And you know, that's what 9 and 10-year-olds enjoy, and it unfortunately rather resembles where we are right now. Fossil fuels, I think, are vital competitors. They have dominated the energy system for reasons related to energy density and convenience and phase fluids and so on. And climate change is highly likely to be a correct description of what we are doing to the planet by emitting carbon dioxide and changing the atmosphere's concentration of that gas that has been a critical gas in the history of the Earth. So we have that. So my best messages were about a hard problem, in fact, an unprecedented problem. We don't have the mental equipment to figure out how to do this. So you've paid me to come here and tell you I have the faintest idea what to do. But let's go a little further. What are the consequences of climate change that would drive us to a decision? Forgive the parochial picture here, but that's Florida and Louisiana and the Gulf, Alabama, Mississippi, and so on. And maps from the climate center that happens to cohabit Princeton with our university, called the Geophysical Fluid Dynamics Laboratory, where the sea level rise of 1, 2, 4, and 8 meters are shown. And what do people today, what are we able to say about likely future sea level rise? It's not too far off, and it's easy to remember, to say that the modeling is suggesting about a meter a century of sea level rise as a number to keep in mind. So that the top left picture would be true for 2200 and maybe the bottom right well into this millennium. On the other hand, the errors are large. No one is really very sure about that. It's truly a risk management situation. And you can do a simple calculation based on the volume of ice on land to realize that the bottom right picture is the result of melting the Greenland ice sheet or a small portion of the Antarctic ice. So we don't know. We can draw this picture. Anyone can. These are the contours of the land, and they've been drawn for every part of every seacoast at this time. And it does look as if one of the important consequences of climate change will be moving cities inland around the world. But how soon? And how much should we today regard that as our problem? If it does happen in 2500, is it our problem? Can we relate these? There is increasing confidence in the ability to relate a temperature rise of the planet, long term, an average temperature rise, to the total amount of fossil energy burned from the past to the indefinite future, what's called a carbon budget. I like to simplify figures so I can remember them, not to worry about the second decimal place. So you haven't seen this figure. I recommend it, that roughly 1,600 billion tons of carbon dioxide goes with each of the first 3 degrees of temperature warming of the planet as kind of a median estimate. So we've already emitted approximately that much, 1,600 billion tons of CO2, and we have approximately expect a 1 degree Celsius rise for that amount of emission. And if we equal that in future emissions, we have approximately a 2 degrees Celsius rise, and we have 3 from doubling, from putting again out twice what we put out already. An estimate of the error bars that are in the community right now is that if you aim for 2 degrees, you have about a 1/6 chance, a Russian roulette chance, of getting more than 3 degrees and being unlucky. And conversely, if you aim for 3 degrees, there's about a 1/6 chance that you could get a windfall and end up with 2, because the underlying science of the Earth is very far from fully developed. It's all about feedback loops, perfectly straightforward to understand why it's hard. We don't really understand clouds. We don't really understand ice. We don't really understand forests well enough to fully understand the consequences of the carbon dioxide rise on the planet. And so we are talking about risk management. One of the failures of communication of this subject, as far as I'm concerned, is that we don't use the phrase risk management. The environmental community doesn't like it. Politicians don't like it. But business people live with risk management as an underlying principle of getting up in the morning and managing risk and going home in the evening. That's what you guys do. So if there are carbon budgets, if that 1,600 billion tons of CO2 per degree is an operative principle, consequences are very severe, because it doesn't take, as I'm going to show you in a moment, it doesn't take very long to use up a carbon budget of that scale in terms of planning horizons of businesses and government and the rest of us. So we're going to have to face a completely new set of questions if we confront carbon budgets, which is, when are we going to pull it out? And because CO2 is so long-lived in the atmosphere, there is a kind of indifference on the planet's part to whether we burn some CO2 in 2020 or 2070. Whose carbon is going to get pulled out of the ground and used where? Those are not the same places, as everybody in this country knows. And for what purposes? Are we going to confine it to certain sectors? And what about the fossil fuels themselves? Is there any differentiation between pulling out natural gas and pulling out coal? Well, one observation is that when you pull out carbon, you're also pulling out hydrogen, and the hydrogen gives you energy without carbon. So the more hydrogen that comes out with the carbon, the better the use of the budget, which everybody in the natural gas industry has figured out and makes them rather sympathetic to some amount of climate policy. And everybody in the coal industry has figured out and makes them rather unsympathetic to climate policy. It's just because of the carbon-hydrogen ratio. So science actually can be helpful in laying out some principles. And there is a developing understanding that we're really dealing with something called unburnable fossil fuel. Very unpleasant conversation. Very, very unprecedented conversation. We don't talk about unburnable, unminable tin, but we are talking here about unminable fossil energy. And who decides? What processes will arrive at answers to these questions? To this slide, which on the right shows a picture taken out of a helicopter above the oil sands in Alberta by me about 10 years ago, of some of the largest shovels and trucks in the world. Many of you have been there. Also says that, we're not going to solve this problem by depletion. We're not going to run out of fossil energy before we run out of room in the atmosphere for the carbon dioxide it will make, unless we're clever. So one of the myths that is powerful, because people don't like cognitive dissonance, they want to believe this problem will solve itself, is that there isn't all that much hydrocarbon. The words peak oil were around not that long ago, and they were greatly generalized by the general public to mean this problem will take care of itself. At least that's my view. And I think it's been shattered. The discovery of the rapid expansion of shale gas in the United States, a whole new category of fossil energy. The fact that India and Japan are investigating clathrates, that you guys are going into deeper coal seams for methane. All of this is reminding everyone that there is an enormous amount of buried hydrocarbon. Not too many people try to estimate it. You have to make some pretty wild guesses. But there's some literature on that, and there's a guy named Rogner at IASA in Vienna who quite a while ago published one paper, and they published several more, and the numbers are gigantic. We already have got in our heads that 1,600 billion tons of CO2 is a degree Celsius of temperature rise, and we have an estimate here of 70,000 billion tons versus 1,600 per degree. Immense. And credibly, if there were no climate problem, we would have a millennium or two based on fossil energy going after the unconventional ones in due course. Probably with not all that much price rise because we get clever at bringing it out. And so we have, this is where I call this paradox. We have the fossil energy available, and we can't burn it. Two pictures to go with 2 degrees and 3 degrees Celsius are here. If we can represent the history of fossil energy by a triangle that took 80 years to get to today's level, which is about 40 billion tons of CO2 per year, the emissions right now. And if it's 80 by 40 and you multiply by a half because it's a triangle, you represent 1,600 billion tons of CO2. I like these simple models. And if we're going to have a 2-degree target, this is approximately what the world is asking for if they ask for a 2-degree target. We go down the opposite, the backside about as fast as we came up the front side. In 40 years, we have cut global fossil energy emissions in half. That is approximately what the IPCC says. It's a picture that many people had in their minds about peak oil with, of course, different coordinates. And that triangle, or that isosceles triangle, is the 2-degree world. A 3-degree world slots in a rectangle. And for example, and therefore we're on a plateau for 40 years. 40 years, 40 billion tons of CO2, an extra degree. So that gives you a descent in about 2060, but no further growth in fossil energy right now. And investments that produce fossil energy in 2060, much under examination. The gas and oil people would like to substitute gas for coal. Here's a picture of 40 billion tons of CO2, which is 2, 2, and 1 coal, oil, and gas today, and becomes 2, 1, and 2, with gas taking 1/2 of the coal market share. That gets you about a 10% improvement, extra energy for the same CO2. It's not nothing, but it's 10% because 1/5 is being changed by about a factor of 2, so at best. So one can ask the gas industry to figure out how to take some market share from coal and at least have a conversation about that. What else is there to do? Well, there's carbon capture and storage. Chris Greig, my host, has been one of the pioneers of this subject of carbon capture and storage. My own research group has been involved in this for a long time. It's going nowhere, or nearly nowhere. One reason being that 2x2 matrix you had at the beginning of the talk. If you're in the bottom left quadrant, you want renewables to triumph. You want nothing good to happen to the fossil energy industry. If you're in the top right, you think that this climate problem is silly, and why on earth would one add to the cost of fossil energy to put CO2 below ground that came out of burning it? If you're in the bottom right, it's interesting, but you haven't got many friends who aren't in the bottom right quadrant. So the more we really do move to the bottom right quadrant, the more I think we will have serious interest in doing this very difficult and expensive job of putting CO2 into the ground, which, by the way, has surfaced for a second function, particularly in the last round of the IPCC, where we're talking about negative carbon. Negative carbon is taking CO2 out of the atmosphere, not out of the subsurface, and then putting it below ground after some intermediate step, which might be growing a tree, and then burning the tree, and capturing the CO2 and putting it below ground. That's negative carbon. We're scrubbing the atmosphere. So too is blowing CO2 over a chemical like sodium hydroxide, having it form sodium carbonate, retrieving the carbon dioxide and putting it below ground. There are various negative net carbon strategies. Note that both of those require putting CO2 below ground. So it's the same second part of the CCS strategy. They're not the only strategies. You can augment the stock. You can put additional carbon into soil, for example, but that's not easy to do. So that picture, I don't really have time to go through it, but it was in a paper I wrote in 2005 called Can We Bury Global Carbon? That was in Scientific American. And a lot of people kibitzed about what should be in that picture, where we actually tried to show by scale how much CO2, what kind of volume was required below ground for CO2 produced by a coal plant of a given size after a given period of time. And the number one technological uncertainty there was what's the fraction of the below ground pore space that CO2 could actually occupy if you're very clever at inserting it. You can go back over that ground sometime. I'd be happy to talk about it. The US, as many of you know, and not many other countries, has a highly developed CO2 pipeline system for enhanced oil recovery. So we have a feel for what a carbon dioxide system would look like that was designed primarily to put the CO2 below ground. And for the oil and gas people in the room, one of the things that I think is potentially on your horizon is if there is a substantial price for CO2 emissions, then the enhanced oil recovery business looks different because you're getting a revenue from two factors, from the oil you're producing and from the CO2 you're keeping down. And you might do it quite differently. Today you try to have as little CO2 stay below ground as you can because you bought it and it's expensive. If you're paid for keeping it down there, you'd have a quite different industry. I think this is a frontier for some of the people in the upstream oil sector. We've got to talk costs. I mean, the muffled voices about carbon pricing are an embarrassment, or if you like, an indication that we aren't serious yet. There are the carbon pricing that is in the $5 to $10 a ton of CO2 range can make people feel good, can indeed produce some revenue streams for government that are interesting, but they will not lead to an investment pattern that amounts to much. And if we're talking about solving the climate problem, we're talking about new classes of investments and deterring present classes of investments. So to make myself unpleasant, I'm putting $100 a ton of CO2 in front of you as the kind of cost that really would generate new behaviors on the parts of your industries. And one of the things that we need to do together is to figure out what does it generate? What actually would happen if we have $100 a ton of CO2? Credibly, not something that they think will go away with the next election. So $100 a ton of CO2 is $40 a barrel, just counting the carbon atoms. It's $5 per million BTU, which is the unit of gas that many people think about, and it's $200 per ton of high-quality coal. You can relate that to the current costs. Swings of oil up $40 a barrel and $5 a million BTU are familiar in the gas and oil world. This coal increment is not familiar. It also translates at the retail level to rather modest increases, 80 cents a US gallon. You can translate that into Australian cents per liter. 8 cents a kilowatt hour for coal-based electricity, 4 cents for natural gas-based electricity. The retail customer is shielded by all the overheads, all the transactions that follow the extraction from the ground. So the consequence of a CO2 price, substantial CO2, are largely felt by the extraction industries and much less so by the retail units. It's obviously, to me, it's obvious that you have to have the tax as far upstream as you can, so there's none of this fugitive stuff that doesn't get taxed at all that would have been easy to collect. But so we have to internalize this. And I think the industries badly need to help the governments and the NGOs and others understand what does happen, which is token prices and which are not token prices, and the detailed structure of prices that make this work. To try to do carbon policy without a carbon price is, of course, possible. We're doing it right now. But it would be a more efficient, orderly process. Some low-cost opportunities would not be missed if we do this. If we had what I call price plus, we start with a carbon price. There's a lot of interest in your industry in what's a stranded asset. And I've been thinking a little bit about how to think about stranded assets, and I've got this up arrow and down arrow. You can't strand an asset until you have an asset. So the up arrow is we make an investment, and then something happens and it's stranded. What happens typically is in government, but it could be a science surprise, it could be a political change. All of you know that. And what are the likely stranded assets? Well, it seems to me that the proven reserves that are on the books are not likely to be stranded assets. Although that is where the argument is now occurring in the environmental movement, that we look at how much we have already on books, that if we produce that, the CO2 will rise by a certain amount, so we mustn't produce those reserves. But on the other hand, where you're making investments in new reserves, in opening up new provinces, new mines, it seems to me that's going to be the scrimmage line, to use U.S. football, or the scrum is fought there. Because those are the consequences that are going to affect the third degree and the fourth degree of temperature rise. And somehow you have to find a way to interact with the rest of us about these decisions that really affect the middle third of the century. These are the decisions you're making at the board level very often about new provinces. This is where I think the rubber hits the road. It's extremely unfamiliar and difficult, but it seems to me this is where we have to sit. One of the things that I find sobering is that I don't like a single solution to climate change. And I think all of us actually don't like them. That's why we're in the bottom right quadrant. Conservation done badly, or any of these done badly, can be quite a mistake. Conservation can be regimentation, take away a lot of individual liberty. Renewables can decimate land used for other purposes. The consequences of thoughtlessly pushing for biofuels and not thinking about effects on food markets. That shouldn't have happened. We're perfectly capable of figuring out what was going to happen ahead of time. Clean coal, which primarily means CCS in this vocabulary, is greatly disliked by those who want really, first of all, to see the coal industry take major strides all over the world, because all of this has got to be global, to make sure that mining is a responsible enterprise. Nuclear power, in my view, the number one issue is it does enable nuclear weapons in lots of new countries when it's done globally, which can in turn lead in regional rivalries to nuclear war. And we've got to have a nuclear power system that is sufficiently international and that has been thoughtfully decoupled from the nuclear weapons structure. The Iran agreement reached this past few months has some of the dimensions of that. A country is compromising its own sovereignty in order to conform to its own politics, which says we don't want nuclear weapons, and make it visible to the rest of the world. It's coercive, but acts of that sort can really be part of our future. And then there's geoengineering, which some of you have learned something about. There are a lot of scientists and engineers eager to save the world by providing new technical solutions which are very aggressive toward the planet. We haven't had any public discourse, although there's a lot of involvement in the academic community, particularly among social scientists and humanists, about what this is all going to bring. All in all, I think the phrase here, where I'm most comfortable, is that we must consider the risks of disruption from climate change and the risks of disruption from mitigation side by side. In fact, I have a favorite philosopher for this, to make this point, who's Hippocrates. And in a modern version of the Hippocratic Oath, which in shorthand says, do no harm, expanding that says, I will apply for the benefit of the sick all measures that are required, avoiding those twin perils, those twin traps of overtreatment and therapeutic nihilism. Most of us, by the time we're old enough to be in this room, have had some brush, perhaps a parent, perhaps ourselves, with a very serious illness where the doctor and the patient together are trying to figure out whether to use some extreme treatment. And something of that, the flavor of that, is what we're confronting when we're dealing with the solutions to climate change. They can be done very badly. We don't know them fully. We have to have our eyes wide open. We need especially what I call conditionality. We will take this on, but only if we're also thinking about treatment of the land when we go to biological solutions, nuclear issues that we know very well. So I have just 2 slides on recommendations. We absolutely have to get started. And I think Maxwell was right when he said that the Paris negotiations represented getting on the front page, getting on the first page, not the front page, the first page. We are finally organized without this hobbling of only some countries have to act and the others can do nothing for a long time. We're now agreeing that's a world problem. We have now asking for voluntary measures by national governments. We must also ask for voluntary measures from industry. And what can you all do? Well, first of all, taking care of your own industries. So upstream carbon dioxide emissions, flaring has reappeared in North Dakota in the United States because people have been in such a big hurry to pull the oil out. When there's associated gas, they flare it. It's a scandal. Should never have been allowed. The oil industry is embarrassed that it's happening. And it probably has affected its ability to operate in some countries outside the United States, that it was so lax about getting going with in states that didn't have the regulatory apparatus and so forth. Promote CCS, where there's low-cost CO2, as in gas processing. Redesign enhanced oil recovery for when CO2 storage is actually profitable. Fugitive methane, something which the United States has now put a great deal of new policy in place, which is driving the oil and gas industry nuts, to make sure we don't have gas leaks that could be easily found. Gas for coal, to what extent is that a real proposition? And gas for firming. This is something which is interesting from a philosophical, from a conceptual perspective as well, that intermittent renewables are a real headache. Natural gas is relatively easily turned on and off in natural gas turbines. They go together. They're natural dancing partners. Renewables people don't want to acknowledge that. And the natural gas people aren't particularly eager to acknowledge that, although there is an ad in Heathrow Airport from, I think, Statoil, saying we're the natural partners of renewables. We have to develop those hybrid solutions that are partly renewable and partly fossil. And one of my colleagues, my closest colleagues, works on coal biomass combinations, that would, including capture and storage. But when you have the biomass and the coal going into the same gasifier or boiler, and then you capture the CO2, you get some negative credit for the biomass part if it goes below ground. Engage policymaking. I've said this several times. I need to stop, but be helpful about climate pricing so that people know what this really can bring. And identify yourselves with carbon efficiency. We say far too little about carbon efficiency. Renewables on the roof of an uninsulated building is not smart. And I have two examples of this. They both involve essentially expanding your own boundaries to include the customer side of the meter. The electricity industry has had to contend with this for about 40 years, what Amory Lovins called negawatts. And they, particularly in regulated electric utilities in the United States, elsewhere, were given a rate of return when they invested in insulating buildings, insulating walls, and putting in efficient refrigerators and so on. We've got to think that way in the oil and gas and coal world. And you guys can tell us you can tell the governments how this should be done. That upper example would bring gas to new cities, assure efficient buildings and appliances. Imagine a gas pipeline being built in China to a new city, 30, 40 kilometers from an existing one, which is right now greenfields. It's going to have 15-story apartment blocks. It will house 100,000 people. It's going to have 30,000 refrigerators. And you don't care. Fossil energy doesn't care how your electricity is used. To some extent, you've got your thumb on this opposite pan of the scale. If they use a little bit more, so much the better. There's really a horizon here for activism and leadership on the part of the fossil energy industries, for new facilities. And for the existing ones, being much more involved with your customers. I know Dow Chemical in the 70s had something of a reputation for helping its customers save energy. It was impressive. Then they taught other chemical companies how to do the same thing, and they had a service sector. I remember that because I think back to that period. Some of these things that happened in the 70s in the first round of activism haven't happened since. Chris Greig is trying to start a new project that I'm strongly encouraging, dealing with, again, something that all of you can help the world understand, which is how fast can change happen? How fast can you gain 10% market share in this or that situation? What sets the limits on that? Is it labor force? Is it particular resources for metal in the ground? We need to understand this because we have not done the homework almost anywhere to talk about pace of change. It's in the models. The models the IPCC modelers are using have got rather arbitrarily market share changing from A to B with some kind of a break that they've invented numerically, but we haven't done the work here. And finally, my last slide. I'm still an optimist in spite of all this difficulty, and for 4 reasons. The world today has terribly inefficient system for using carbon. We haven't really tried yet. The absence of a price on carbon, of course, makes that not too surprising. Carbon emissions have just begun to be priced, here and there. Most of the global infrastructure for 2065, I need to change that to 2066, isn't in place. A tremendous amount of what will be energy using equipment isn't there yet. And so we can do it better. And very smart scientists and engineers and business leaders are now finding energy problems exciting. That wasn't true 20 years ago, wasn't true 15 years ago. This focus on this problem is new to some extent. It was there in the 70s and went away. You're here in this room because you do find the problems exciting. No one was compelled to have this breakfast with me. And so I'm delighted to have this opportunity to talk to you and to get a conversation started. Thank you very much.
Rob, thank you so much for that very provocative and enlightening speech. We've got lots of questions for you, I'm sure. Can I ask everyone in the audience to think about a question and bear in mind we've got limited time, so we'd like to get one question per person, no speeches. And when you ask a question, could you please give your name and affiliation before you ask the question? There are microphones here in the room. Can I ask our two panellists to come up and join us on the rostrum? First of all, Karen Hussey. Karen's a professor at UQ and is a new face in Brisbane, so a special welcome to her. And joining her on the rostrum is a face that's well known to lots of you, Alex Serpantis from Rio Tinto. Who's going to ask the first question? There's one here. No? Just putting your jacket on? All right. Keith Orchison, I think.
Yes, thank you kindly. Thanks, Keith Orchison. I scribble a bit about energy. Rob, one of the things that you and I talked about yesterday afternoon at UQ was energy efficiency, energy productivity. And perhaps, listening to you this morning, that's an area that might be interesting for you to just touch on now. The number that I quoted you yesterday is the IEA one that says with energy efficiency we can save something like 10,000 terawatts of electricity consumption between 2013 and 2040. Thoughts on that?
Well, certainly an easier way to talk about it quantitatively is a given use. Is there any use one can't be clever about and cut the energy demand in half? I suspect pretty much everything we do, we could cut the energy demand in half. And then, are we getting better at it? I worked on energy efficiency in residential and then larger buildings in the 70s and 80s. There was new policy at the time. Appliances did get much better by law. Minimum appliance use. Caps on how much a refrigerator could consume, for example, of a given volume. The world is better in that general area. High-rise buildings, apartment buildings, for the residences of hundreds of millions of people coming out of rural areas into the cities of the developing world, I think are being built about as innocently of energy and other infrastructures. Water probably true as well. We just are not adding smarts. It's not dramatic. It's out of sight, and we allow the literature of energy efficiency in the 70s moved from this is what we need to do to this is why it isn't happening. Lots and lots of papers about split incentives, landlords and tenants, or the knowledge of the customer, or the norms of the architecture community, whatever it is. There was one thing after another, and they were all still there. So the opportunities, it proved that it was hard. But if we really took an interest in what was being built for the first homes in these 50 square meter homes that are being built for the apartments that are being built for hundreds of millions of people, we really took an interest in that because they're burning your fuel. Or they could, either directly or as electricity that you made. If you really took an interest, how fast could we make that change? But we could make a dramatic change. Your gas will go twice as far. I don't like adding up the numbers of all the countries of the world. I mean, sure, it'd be big. But if we just think we cut the demand in half in almost anything we've really worked at, that goes for the industrial sector too, although Where fossil energy is a more expensive fraction of the cost, so say with aluminum, you're going to have not big savings opportunities. So people have been thinking about it. But wherever it is not a big fraction of the costs, which is all over secondary industry, commercial sector, and so on, stores, there's tremendous savings available. The LED will be an important invention, maybe the most important invention for climate change at the present time. We need to think about that whole system.
Rob, you made the point in your presentation that there's going to be more than one solution to this climate change problem.
Absolutely.
And this is fundamental. By the way, we're going to give both of our panellists the opportunity of making closing remarks at the end. But if either of the panellists want to chip in with an answer to add to Rob's response, just raise their hand and we'll give the opportunity. I think they both do. And there's another question here after that, up the front. Sorry, we'll have a response from the panel first. Karen.
Well, just simply to heartily endorse that. The single largest infrastructure in the world is the urban environment, suburbs. Right? It's critical, and it's an enormous amount of opportunity in order to reduce greenhouse gas emissions by increasing efficiency. But I would argue that, like any of these issues, we can't encourage energy efficiency in isolation from pointing out the other win-wins. Right? So very rarely will householders or even governments decide that they want to pursue something dramatic and often quite costly, like energy efficiency, costly in the short term, unless you can argue that there are multiple win-wins. And the beautiful thing about redesigning, restructuring, retrofitting, and thinking cleverly about our urban environments is that there's a win-win from a greenhouse gas perspective, but there's also a win-win from a water security perspective, from a back pocket perspective, from a biodiversity habitat perspective. So if we think really cleverly about the single largest infrastructure that we have, which is the urban environment, we can achieve multiple benefits. And I think it's only when you package things up in that frame will you actually get both households and governments acting on it.
Alex.
I absolutely agree. I think energy efficiency has a big role to play, but I think we must be careful not to overstate the role that it can play in reducing greenhouse gas emissions. And that is because what we've seen historically is as we become more efficient at using energy, we actually demand more energy services. And as the world continues to grow in affluence, the number of people demanding more energy services is going to grow also. I did a simple thought experiment a couple of years ago now where I looked at the Ford Falcon, which is a large Australian car. I looked at a 2014 Ford Falcon, I looked at a 1972 Ford Falcon. They both served exactly the same role in the Australian mobile market. They have, surprisingly, about the same fuel efficiency in terms of miles per gallon. But the Ford Falcon of 2014 weighed 40% more. It had literally 2.5 times the power, and it had many more services in terms of comfort, luxury, safety, etc. So whilst the engine which drives it was much more fuel efficient, if you look at kilowatts per litre of fuel which is used, rather than having a smaller engine which uses less fuel and produces the same power, we've gone for a more powerful engine which uses the same fuel and produces a lot more power, and bundled into that package a lot more services as well. So we need to be a little bit circumspect about the ability of energy efficiency to get us to where we need to get to. It simply won't by itself.
Good. And
but it's a very important part of the puzzle.
Very good. Question at the front.
John Cole, University of Southern Queensland and UQ Business School. Robert, you introduced the concept of product stewardship when you talked about the fossil industries looking beyond just the sale of its product to how it's used, etc. And I guess, Alex, I'm, in addition to Robert's point, interested in whether or not concepts like product stewardship are getting any currency in large companies like Rio. Or where is the state of the game in that particular place?
You should answer.
Well, product stewardship has a very large profile in large companies like Rio Tinto. We actually have a product stewardship group within Rio Tinto. Large companies like Rio Tinto recognise that we have a responsibility that goes beyond when our product leaves the gate. But we also recognise that we are just one relatively small part in that broad value chain. So why does Rio Tinto and why do other resources companies produce resources? Well, because we all demand those resources. Society has decided it values those resources, and companies like Rio Tinto provide those resources which are demanded by society. If I can focus specifically on the coal industry, which is obviously the most relevant industry in this particular discussion, product stewardship is very well established within the coal industry. The Australian Coal Association Low Emissions Technology Company, for example, which is funded by Australian black coal producers, has committed about $350 million towards the development of low emission coal technologies. Now, to my knowledge, it is the only industry in the world which has committed that amount of money, which has no possibility of any direct return. That money is essentially a donation towards the development of technology. But we're spending other people's money. So the amount of philanthropy, if I can call it that an industry can engage in, is limited by our fiduciary duties as agents representing our principles. So our shareholders will allow us to spend their money for these pursuits because it's an important pursuit, but the reality is it's limited. So the industry needs to work absolutely hand in hand effectively with governments and with broader society in order to progress society's objectives and needs. I think there is sometimes in this debate a tendency to point the finger at what was called in Australia the big polluters, you know, the large emitters, the coal mining companies, the gas companies, etc., and say, well, it's their fault. They need to fix the problem. We can't fix the problem. Society needs to fix the problem. We need to play our part. And product stewardship is how we do that.
Okay, well, we'll take a question from the back of the room now.
Thanks, Bob. Stephen Wilson, Cape Otway Associates, and one of many Rio Tinto alumni in the room. Robert, I wanted to join three dots from your presentation, which are $100 per tonne of CO2 carbon price, EOR stroke storage of underground storage of carbon, and risk. And the question is, for companies to be motivated to store CO2 underground, which pricing model do you think would be better? One where they receive $100 per tonne of CO2 up front and then store the CO2 in perpetuity, or one where they receive a small annual payment equivalent to $100 per tonne up front?
What was the second?
A small annual payment equivalent to the upfront lump sum.
Well, I think that's the kind of question, this is maybe not fair on my part, but where you guys can help the policymakers and to some extent the environmental community who presses the policymakers to distinguish among a more and less effective policy. I don't know. I'm not fully sure I heard the question, every bit of the question, but this is exactly where I'd expect you guys to say, we would be more motivated by this or that. What I do know, and all of you know, is that if there is not a sense that the policy is here to stay, investment doesn't happen. So how you develop a consensus that this is something that society really wants to do, whether there's a change of government or not, probably is more important than the choice you just suggested, or the choice between cap and trade versus a carbon price and sweet spots in the middle. And you can talk about regulatory design, but I think the really point is, how do we get something that makes people happy to have it because we're solving an important problem we care about? I don't think we're scared enough about climate change at the present time to expect some of this to happen. And one of the things I hope I said is the world is going to tell us how vulnerable we are. And it's going to tell us it in a relatively short order. And we will then, so the fossil energy industry needs to be managing risk between outcomes that will tell us that we've got to get going in a serious fashion. And $100 a ton of carbon dioxide is called for. Versus the happy outcomes that we cannot count on, must not bet the farm on, in which it turns out the Earth is relatively less twitchy, a phrase my colleague Pakala uses. We don't know. We've got to be prepared for both at the present time. That's how I think about it.
Next question. There's one here at the front. Thank you. Got a little nest of questions.
Yeah, it's a terrible table. Jim Snow, Oakley Greenwood. One of the things that people forget with increasing the price of fuel which has a direct impact on the reduction. We've seen it here in Australia. Electricity prices have gone up, consumption's going down, it's happening in the gas industry as well. Is it then completely restructures your economy? I mean, there's not just a benign impact here about displacing one fuel with another or one technology with another or energy efficiency. It completely restructures your economy at the same time. I mean, we are seeing a mass exodus of energy-intensive industries into areas where it's cheaper to produce. So you end up with this other problem, is that it's not benign. I mean, you have to take into effect that over the next 20 to 40 years, you will completely restructure an economy. Be interested in your comments on that.
Okay, I think the whole panel might have a comment on that. Start with you, Rob.
Well, I agree, but the point is we have to do it, or we have to be at least halfway along to doing it, understanding what it's going to mean. Restructuring an economy is a very big deal. It's nothing we wish we didn't have to do it. So yes, and 20 to 40 years, yes, not 5. But that's a planning horizon of many of the people, most of the people in this room is 20 to 40 years, whether they're inventing an academic program or they're trying to decide on whether to go to a new part of the world and build a mine.
Well, I think the emphasis in Paris from the political leaders was we're going to have to go through a transformation.
Right, and whether that turns into actual behavior in the countries or fudging is something we haven't decided yet.
Yeah.
And
Karen.
Well, I would simply add, I think that's absolutely right, and I would put it very simply. There's going to be pain, right? It's going to hurt, and we know from history that all major societal transformations have resulted in one or more parts of society going without. And you can look at the civil rights movement, you can look at the Civil War if you want to go back a couple of hundred years in your country. Somebody is going to lose from whatever the new system looks like. I think it was Machiavelli who said the single biggest thing you can do as a politician is advocate for a different system. So what we've got to do is just acknowledge that and say there is going to be pain. We're going to have to invoke significant structural adjustment. It's a small example, but I come from a trade, among other things, a trade background. And I was saying to Alex last night over dinner that you may recall in the 1980s, Australia and New Zealand went further than any country in the world to liberalise our economy. And the agricultural sector was slugged harder than any other sector in the world, or in the country and arguably in the world. But there was pain, there were payoffs and compensation. It was a pretty awful time. 10 years later, we saw that sector emerge as the most efficient, most innovative sector, agricultural sector in the world. So out of pain and hardship can come incredibly positive benefits, but you've got to acknowledge that there's going to need to be some pain relief, and that'll cost money.
Alex, do you want to add anything?
I'd just like to add the observation that we currently live in a global economy, and the reforms that you mentioned, of course, go back to the 1980s. That was in the age of protectionism, tariff, trade barriers, etc. Many of those have now been removed. So Australian industry is, for the most part, fully exposed to the global economy and has to compete on its merits. So what does that mean in terms of being able to reform Australia's economy, our industrial base? It means that it's actually dependent upon demand for those services from the world as well as domestic consumption here in Australia. So it's a much more challenging task, I think, to try and change the economy of a country now, given that it's so interconnected with the economies of all other nations. We don't hold all of the levers anymore. A lot of the levers that we used to have, tariffs, all of that sort of stuff, have been removed. It's much closer to being a purer free market. So what that immediately implies is that it's actually the global economy that needs to transform. And what we need to do in this country is ensure that we are contributing to that transformation. But there's great risk in getting too far ahead of the curve, as Rob said earlier today. You need to consider the risks of your actions to challenge climate change, as well as the benefits. So it's a careful balancing act that we need to take.
I don't think it could ever be described as having been ahead of the curve. I think Germany is instructive here. So Germany picked winners in a way that I don't think we should. They said we're going to pay 20 billion euros a year for the next 20 years, nearly €500 billion to back solar and wind. We all benefited. Hands up if you have panels on your roof. Hands up. Right. Well, we can afford that because Germany invested in it. My advice, if you like, is thank you, Germany, for setting the standard, but let's not do the same, because I think we need to be technology agnostic. So we're not ahead of the curve. We're nowhere near the curve at this point. But if we're going to be, I would argue that we need to be very technology agnostic.
Technology agnostic, is that the same as technology neutral, which
Yes.
is the mantra of...
So I was raised Catholic, so
Okay.
everything's in religious terms.
That's good, because the logo or the theme of the Energy Policy Institute is that technology neutrality is absolutely fundamental, as well as being apolitical, of course.
We
Now,
are
there's a
singing
question
from the
up
same
in the
song
back
sheet.
here.
Yeah, Mark Hibbert from Oricon. I'm a power system engineer, worked in the industry for 35 years. And some of the numbers you put up, Professor, earlier made me think about a possible hypothesis. If we have a 1 in 6 chance of getting lucky and getting 3 degrees improvement, and a 1 in 6 chance of getting unlucky and having a further deterioration, it looks like there's a better than even chance that we'll maintain the status quo, given what we've been doing already. And if that's the case, won't it give us another 40 or 50 years for the price or the cost curves of fossil fuels and renewable sources to cross over, and then the problem's fixed anyway?
Where does the estimate of 50 years for crossover come from?
Could be.
I mean, it's crossing over in some sense already. They complement each other, as I talked about. We're going to leave renewables in benign neglect for 50 years? Is that the proposal you're making?
No, just keep doing what we're doing for another 40 or 50 years and we'll probably solve the problem without any significant extra efforts.
I showed you some pictures to say that if we kept the plateau of emissions at 40 billion tons of CO2 a year for 40 years, and then came down the other side, that's a 3 degree C future. Maybe the best we can achieve, but we're not going to achieve that. We're not going to have 40 billion tons of CO2 emissions instead of 80 without a great deal of work, because the rest of the world is developing. It's developing on the basis of coal. And we're not, it hasn't been flat, it hasn't turned a corner in any sense yet. So we're not going to get the 3 degree future, which you could argue, which you may be speaking for indirectly, without a great deal of deliberate decision making, a kind that we haven't gotten used to at all. And we can put this off and say, well, but we're going to have a lot of climate change, and the question is how much is tolerable, and how horrible is it, after all, to have slightly more expensive fossil energy and a great deal more efficient system. We can be proud of some of what we can accomplish.
Well, we've had politicians in this country that have called climate change a hoax, but I think, as you have in North America, but it appears pretty clear from the Paris meetings that it's not an acceptable response anymore. It doesn't have any legs at all. To what extent we can calibrate the release of emissions with actual increase in temperature is obviously an inexact science, but certainly we've reached the point where there's a global consensus for the first time that swift action and decisive action must be taken, and there will be a lot of pain associated with it. Next question. There's two over in the back here, so we can take at least one, probably the two.
Hi, there's a question in regards to this $100 per ton or whatever sum for CO2 pricing, which is a reasonable idea, and we've been talking, as you probably know, for a while about this level of thing. The question is that if you introduce this price, let's say in Australia or in US, it obviously will result in a more than globalized economy, globalized and share market driven economy, that most of the companies will shift their manufacturing to the countries with a much lesser carbon price, because obviously the cost of electricity, the cost of power will be less, which may in turn basically do nothing in terms of the cutting the CO2 emissions, but driving the manufacturing out of the countries and essentially turning them, like if you do this in Australia, have a risk of turning Australia into a resource country with a completely no adding value to this. Just dig it off the ground, send to the place where the processing cost will be lower due to the lower power and low labor costs.
So what's the exact question you put
The question is, on this one, is this pricing, carbon pricing, and I absolutely agree with this idea, makes sense to be introduced in a single country or in a single region rather than globally, and how you think this thing should be tackled from the policy and funding perspective.
I don't know that your question is any different from any other social change which affects costs, such as worker safety, such as air pollution emissions. It may be bigger when it gets to $100 a ton, but it already is used routinely by industry to say, if you put this new rule in place in this country, in our country, we will move our facilities to somewhere else. I mean, this is a familiar story, and it does take coordination. There's the concept of border taxes. If you have an internal tax, and somebody tries to make the same product somewhere else and bring it back to you, you can say you're going to have a tariff on it. That often leads to the second country producing a parallel regulation. For sure, a single country getting way out in front of everyone else will sabotage its domestic industry. So that's not how it should happen. And fortunately, this Paris event, with all of its dreaming, also put in place the structures for dealing with questions of this sort. Because we agree that we're all in the same boat. And then the point is to have change, to have fewer emissions. And it's not going to work if an industry moves from place A to place B and is exactly the same industry at the end of it. If everybody knows that, then that's the beginning of the question, not the end of it. You don't give up at that point. And we have a lot of experience with social change moving across various countries. It typically stopped in the developing world. So now we have a question: how do we keep some kind of harmony so that harmonious policies, including the developing world? And we no longer have this dodge called Annex 1 and non-Annex 1, which made the question unacceptable to raise. Now it's there.
Karen, I see you nodding.
Simply to say, the United States has the Waxman-Markey bill ready and waiting to go for border carbon adjustments. The European Union already has 500 products listed on its border carbon adjustment legislation. China has exit fees drawn up. So, fast forward 2 or 3 years, and we're going to see I think a major game of, if we're going to put a carbon tax or a price on carbon, a constraint on carbon, whatever you want to call it, and you want to import or export to us, I'm sorry, and you don't have a comparable price or constraint on carbon, we're going to give it to you whether you like it or not, or you lose your market. To me, that's actually quite a fair way to address, first of all, carbon leakage, but also the inequity of one country moving further ahead than another.
These games can go awry. There's no doubt they can go awry. And underlying this whole is that we actually decide we have to do something about climate change. If we're all doing this as shadow boxing, then it won't go. So the underlying question and why we're here is that this really looks like an important message is that we are active enough on this small planet to change it to our detriment. That was never true before. If it really is true, we have to make some changes, which it doesn't sound all that hard to deal with border taxes compared to some of the other things we're going to have to do.
Okay. Alex, do you want to add anything to that?
I don't pretend to speak for industry. However, I would observe that industry wants to see change as well. But what industry wants to see is change done in a way which doesn't impact upon its competitiveness. So once again, it comes back to fairness. If there was a global price on carbon tomorrow of $100 and it was a global price, most industries would go, okay, fine, that's just something we'll add into our cost base, and we'll readjust our strategy, and we'll find a way of developing a competitive advantage in an environment with a $100 per tonne carbon price. As long as it was everywhere, it wouldn't be a problem. Bit of an oversimplification there, but basically that's not far from the truth. So industry is not opposed to action on climate change, far from it. Industry is supportive of action on climate change, but industry wants to see action on climate change which doesn't impact upon its ability to compete. It doesn't want to see action which it sees as being unfair.
Well, we've got time for two last questions. I'm going to ask one of them, and I'll keep that till last. So we're going to have one last question from the floor. It'll be from over here on the...
Good morning. Thank you, Robert, and the panelists. It's been a really interesting discussion. I really appreciated understanding the magnitude of some of the numbers around fossil fuels, and I understand completely the urgency of dealing with climate change from a fossil fuel perspective. But, you know, there's a lot of other things in the media that I'd appreciate the panel's comments on, of other things that affect climate change. The two that have been swirling in my mind have been animal farming and population growth. Those two also, I believe, from the numbers I kind of do in my head, could be equally or bigger impact on climate change than fossil fuels. I wonder if you could comment on those two aspects. To what extent are those kind of things thought through in climate models? You know, if population growth were to be increased or decreased, does that have as much of an impact on the kind of topics you're talking about? Those are other societal things I think we have to deal with that are often left out of these discussions.
Biological carbon changes in the stock of carbon on the planet also affect the CO2 in the atmosphere. And today it's about a 1/4 effect compared to 1 for fossil energy. When you count deliberate deforestation, you can count, it's harder to count things like the animals on the planet. That number doesn't change all that fast as far as I know, but if there are various biological carbon terms. They are not as big as the fossil energy terms today. They were 75, 100 years ago. Fossil energy has risen dramatically, and the agriculture and forestry have not changed as dramatically. So they aren't big numbers. Population, I always say that any talk I give, if I don't mention population, will come from the room as a question, and it did again. And it's complicated because I think we're going to be dealing with a different population problem in much of the world, perhaps not Australia, which is wealthy countries are now below replacement level in the sense that moms have less than 2 kids each in much of the wealthy world this time, Japan, in Russia, much of Western Europe. And we're going to have to ask the question, are we actually going to be comfortable with falling populations in parts of the world? And I think from an environmental perspective, we ought to try to be there. We'll have a growing, shrinking population and an aging population. In the major job of getting birth rates down was done in the last 50 years in much of the world, not Africa, not in the Middle East, which is wealthy and still has big families, but in much of the world. And so this problem is somewhat of last generation's problem.
Okay, I'm going to ask the last question. And the answer to the question, obviously, I'll look first to Rob, but I'll use this opportunity to ask Karen and Alex to make a closing remark or response to the question as they wish, and then we'll have to bring the formal proceedings to an end. But the last question relates to one I've been wanting to ask right from the beginning, and it relates to technology. The interesting thing I thought about the Paris conference was that on the evening that the conference was opening, President Obama stood up with Bill Gates and announced that they had thought or come to the conclusion that technology was the answer. I know this is a very generalised way of putting it, but that was their conclusion, and they called upon the Paris participants to embrace the need for innovation in energy technology. Before I ask Rob the question that relates to this, I'd just like to share with you all that the Energy Policy Institute, as most of you know, exists for the sole purpose and the only purpose of better energy policy. We are not an advocacy group, we're not associated with government, we're not owned by the government, which some people get the impression we are sometimes. We're a private sector body, but we're independent, we're totally apolitical, we're totally technology neutral, but we think that technology hasn't been given the run that it deserves in the debates. And we think that changed a bit in Paris. Now, just to give you the evidence for this, we actually came up with a position that technology in general was the area in which we needed to make much greater investment and put much greater effort, both in policy and in practical terms. And we've decided that the conference on the 18th of March, our annual conference, which we call the Energy State of the Nation, should be devoted to how do you integrate energy policy and climate policy. And our suggested approach towards it is technology. And we think this is the most important single issue that's been on the agenda for the energy industry for the last so many years, maybe for the whole of history. We, of course, have invited the politicians to be associated with our conference, but the Prime Minister's too busy to come. Understandably, he's got a lot of things on his plate. Prime Ministers do. The Minister for Resources and Energy is also unable to come, as is also the Minister for Environment. So I'm not suggesting that this isn't a priority matter for policymakers, but I am suggesting that our policymakers are so besieged by demands for immediate attention to a whole raft of other things, very deserving causes, that they don't have time to focus on the issue. I just wanted to ask Rob, if I could, what did you make of Bill Gates turning up in Paris?
I've actually thought about that a fair amount because Bill Gates has been interested in the clean energy issues, maybe number two in his interest, where number one is public health and developing world, for some time, and I have one close friend who has been supported by him and who advises him. I wrote that friend right a week or so later than that moment you're talking about, and said, has anybody decided on the modalities by which private money will be added to the government support for technologies to deal with climate change? And the answer was no. They've gathered the money, but they haven't decided how to spend it. And I want to put that as a question to you all, because I think they're even ready for advice. Particularly this question interests me. If you could spend that money, let's make it simple first, entirely by augmenting the budgets of the research funding institutions of the government, the United States to be the National Science Foundation, the Department of Energy, their equivalents here. So it would be open solicitations from the research community, minimal demands on intellectual property on the one hand, or you could put it all into venture capital, looking for the clever new idea, tying the development closely to intellectual property so there would be little revealed at early stages. Which would be more productive, or would you choose a mix? That's the kind of question I think we actually haven't confronted, and it would be very interesting to have your ideas on that, maybe next meeting, maybe with Bill Gates as your speaker. The other point, though, is different, and that is that we're no longer surprised that the President of the United States stands beside a very wealthy man and talks about what the world has to do. We're moving into a society, I've seen this in so many dimensions now, where we really resemble the Medici of the 16th century in Florence, where the wealth is in private hands and we are expecting the wealthy to solve the major problems of the day and to create the great monuments, the telescopes, for example. We're expecting government not to be able to do it. And we are passing up a kind of democratic governance in favor of turning to people. For the most part, we feel pretty good about what we can talk them into doing. We're good at that. But it really is a loss of democratic governance that is going on at the present time. Private wealth, which is accumulating an unprecedented rate, is being turned to solve education problems, the arts, and a great deal of this dimension of things.
Well, that's a very provocative point on which to close, but I'd like to ask Karen and Alex if they'd like to just add something else at this stage before we formally close the proceedings.
So I would say three things in conclusion, and one of them follows that. Urgency is the enemy of good policy. Right? So when we do things quickly, in a hurried fashion, we tend to make really, really bad decisions. Combine that with the fact that we're trying to deal with one of the most challenging, difficult societal transformations that humanity's ever been faced with at a time when our political system is bankrupt, just makes it that much more difficult. So I think a fool would say it was easy, but I do think it's inevitable. But there's a couple of things within that that we need to keep an eye on. One is timeframes. Okay? There is no example from history of a rapid transformation. Right? We're talking at least 30 or 40 years. Right? Even if we all decided that we wanted tomorrow $100 on CO2, it wouldn't happen, and that transformation would still take time. So I think when we approach climate mitigation, we need to be mindful of this is a 20, 30, 40-year transition. It must be iterative, it must be ambitious, but it must be done in a very careful, considered fashion. The second is, I alluded to before, what did you call it? Technology neutrality. Right? I think that's vital. I've sat on panels where I've had practical punch-ups between one technology advocate over another, whether it's wind versus solar versus CCS versus nuclear. It's really not very helpful, is it? So from a policy perspective, it's really about putting a constraint on carbon, and then you can let all the different actors fight it out amongst themselves. And ultimately, it'll come down to economics. My third point would simply be, we tend to focus on the electricity sector, and that's for obvious reasons, and it's the single most important sector for us to look at closely. But we've got to look at transport, we've got to look at land use, we've got to look at energy efficiency. Right? There's that fabulous McKinsey cost curve of 74 different measures. It's a godsend for policymakers. It's like an a la carte menu. What will we take from the menu today? Right? And the way we approach this challenge must address each one of those 74 issues. And in doing that, take a risk approach. What are the risks of this as opposed to that? And ultimately, that's societal debate. What risks are we prepared to tolerate and accept, and which are we not? And I think that will vary from one country to another. And okay. I'll leave it there.
Alex, have you ever had any punch-ups?
No, thankfully, not.
You don't hang out with interesting people, obviously.
Clearly I've led too far, much too sheltered a life. I think I'll just add one thing, and that is that climate change is a challenge that's going to require change and action across every industry, across every sector of the community going forwards. At the moment, the debate seems to involve a lot of finger-pointing and blaming others. All of us have a role to play in trying to reduce emissions. All of us can tick the box on our electricity bill which says we want 100% renewable power. Something less than 5%, I suspect, actually tick that box, continue to take international flights and have massive personal carbon footprints. So I guess the one thing I would leave you with is if you are concerned about climate change, you need to be working with industry, all industries, because industry, there's a lot of very clever people in industry, just as there are in academia, and industry actually has the resources to do things on industrial scales. So all parts of society need to come together and work in a productive way to try and solve this problem. If we continue to point the finger at others and blame others, it will only slow progress. And I think that's probably part of the reason why progress has been quite slow, because it's seen as a competitive space rather than a collaborative space.
Well, that's a great note, I think, on which to finish. I now want to call on someone, a great friend of mine, to move a vote of thanks. Could I ask Chris Greig to come up to the rostrum to move the vote of thanks? Chris Greig, you will all know, is the head of the UQ Energy Initiative and is the director of the Dow Centre for Sustainable Engineering Innovation. And more importantly than all of that, he's a director of the Energy Policy Institute of Australia. Chris.
Thanks, Robert. So, Robert Socolow, thanks for coming all this way. I get to spend about a month a year at Princeton working with Rob and his team, and it's I get constantly challenged and inspired. I've been trying to get him to come for the last 2 years, and he's finally come, so thank you. I think he challenged us all here, and it was a great talk. But equally thanks to Karen and Alex, who I think were great support for him in the panel and really had a great discussion. And then finally, thank you all for coming. We had a full house this time, so great turnout, and come to the next one, which will be in June, and will feature Ottmar Edenhofer, who is the director of Potsdam Institute, and he's also the chairman of Working Group 3 on the IPCC. And my last thank you is to Christine Deeming and Caroline Stott, who actually do all the work to organise this. So thank you all for coming, and just see you next time.